Imagine an employee ID E101 used by thousands of modules across a huge system. Now imagine one stray line of code changes it to E999. Everything breaks. Java's designers decided some values must never change. That's why, in Java, string is immutable. Let's see exactly what that means. First, string is not a primitive. It's a class. In fact, public final class string. So when you write string name equals tapan, you create an object that stores those characters. And final means nobody can subclass it and break its rules. Now the magic. Write S1 equals Java and S2 equals Java, both as literals. How many objects? Just one. Java keeps a special area called the string pool, and identical literals are stored once and shared. Add S3 equals Java and more. Still one object in the pool with every reference pointing to it. That's a huge memory saving, and it's only possible because strings never change. But the new keyword changes everything. In string S1 equals new string Java forces Java to skip the pool and build a brand new object on the heap. So now there are two objects, the literal Java in the pool plus the new one on the heap. Do it twice, two new strings of Java, and you get three objects, one shared literal in the pool and two separate heap objects. This exact question comes up in interviews constantly. Here's the immutability trap. S equals Java, then s.concat17. Most people expect S to become Java 17. It doesn't. Concat creates a new string and returns it, but we ignored the return value, so S is still just Java. To actually keep it, assign it back. S equals s.concat17. Now S points to a brand new object, Java 17, and the original Java object is untouched, exactly as immutability promises. The reference moved, the old value stayed. So why did Java make string immutable? 4 big reasons. Security. Things like database URLs can't be tampered with. Thread safety. Strings are shared across threads with no locking. The string pool. Sharing is only safe if values never change. And hash code caching. A string computes its hash once, which makes it a perfect hash map key. This powers the famous double equals question. With two literals, S1 and S2 point to the same pooled object, so S1 double equals S2 is true, the same object. But with new, each is a separate heap object, so double equals is false. Double equals compares references. Is it the same object? To compare the actual text, use .equals, which checks content, and that returns true. Remember, double equals for identity, equals for content. Now performance. Build a string in a loop with S equals S plus I 1,000 times. Because string is immutable, every iteration throws away the old string and creates a new one. Thousands of wasted objects. Slow and memory hungry. The fix is StringBuilder. Call sb.append in the loop, and it grows one single object in place. No copies. Same result, a fraction of the work. For heavy string building, always reach for StringBuilder. StringBuffer is almost identical to StringBuilder, with one difference. Its methods are synchronized. That makes it thread safe, so multiple threads can append to the same buffer safely, but the locking makes it slower. Side by side, StringBuilder, not synchronized, not thread safe, faster, since Java 5. StringBuffer, synchronized, thread safe, slower, around since Java 1.0. Both are mutable, unlike string. So when do you use what? Use string for values that won't change, names, keys, constants. Use StringBuilder for heavy editing in a single thread. That's the everyday choice. Use StringBuffer only when several threads share one buffer, which is rare today. The whole picture in one frame, string, immutable, pooled, thread safe. StringBuilder, mutable, fastest, not thread safe. StringBuffer, mutable, thread safe, slower. Know these three cold, and you'll handle almost any string interview question. Interview round. How many objects from string S equals Java? 1. The literal lives in the string pool and is reused. How many objects from string S equals new string Java? 2. 1 in the pool for the literal plus 1 new object on the heap. Why is string immutable and final, security, thread safety, string pool sharing, and hash code caching, and it's final, so no subclass can break that immutability. Double equals versus equals. Double equals compares references, same object or not. Equals compares content. Literals share one object, so double equals is true. New objects differ, so double equals is false, but equals is true. StringBuilder versus StringBuffer. Both are mutable. StringBuilder isn't synchronized, so it's faster for single-threaded code. StringBuffer is synchronized, so it's thread safe but slower. Now it's your turn. Take the topic test and lock it in. 5 multiple choice plus 5 short answers graded by AI. The link is in the description below. And here's something special. Top the leaderboard on 5 topics in a row, and you'll get a surprise gift from me, plus a personal one-on-one connect. From this video onward, that's a promise.